Hi everyone, Mr. Bell Computing here, and today we are looking at systems architecture as part of OCR GCSE computer science. And I'm going to be showing you some exam style questions. And if you find this video useful, please make sure you give it a like and also subscribe to the channel as well, so that you can get some valuable GCSE tips and advice in the run up to the exam. So, systems architecture, let's get straight into it with question number 1. A computer CPU contains registers. Complete the table by identifying 2 registers and state the purpose of each register. I'm going to show you the table on the next slide, but you might want to pause it here and see if you can come up with an answer. But if you look at this diagram here on the right, the registers within the CPU are little storage locations where different things happen. So you've got the program counter, current instruction register, the accumulator, the memory address register, and the memory data register. This is really about seeing which one you remember the easiest when you're asked a question about registers. Ones I find the easiest are the memory address register, because it stores the address of the current or next instruction or data, and the memory data register, because that stores the data or instruction that's been fetched from memory. And the word address and the word data, they're the ones that help me remember those 2 main registers. You got the program counter as well, which stores the address of the current or next instruction to be fetched. And you've got the accumulator, which stores the result of calculations. So any of those that you can remember, that's great. Obviously you want to remember all of them, but let's have a look at the table on the next slide. So I've wrote here, M.A.R. stores the address of the current or next instruction, and the M.D.R, which stores the data or instruction to be fetched from memory. And I think one tip here, to be fair, is although you can write the abbreviations in, it's easier, or probably just better practice, to try and figure out the full name. So you got your program counter, memory address register, memory data register, or accumulator, and you can use any of those in the table for your answer there. Moving on to question 2. A computer has a central processing unit, or CPU. Describe what happens during the fetch, decode, execute cycle. And this is 2 marks, so you need to say 2 things that happen at any stage of the cycle. If we look at the fetch stage, you can fetch the next instruction from main memory. I always remember that one because it's the first thing that happens, all right, in the fetch stage. That would be one of my go-to. Fetch the next instruction from RAM and bring it back into the CPU. At the decode stage, that's where we inspect the instruction to find out what actually needs to be done. And in the execute stage, we carry out the instruction. That could be going back to main memory, performing a calculation, or storing information back into main memory. So, different ways you can answer that question, but you need 2 of these points. Data and instructions are fetched from RAM. Like I say, that's the one that I remember the easiest. Data instructions are stored in a register, so you could say data set is stored in the memory address register. The data and instructions are decoded, and the data instructions are executed or processed. So as much detail as you can, but remember those 4 key points there, because they're things that happen during the fetch, decode, execute cycle. Moving on to question 3. A car has a guide plus system that uses a cruise control to allow the car to follow the car in front of it. It will keep the same speed and distance without the driver's intervention, and the cruise control system is an example of an embedded system. Explain the reasons why the Guide Plus system is an example of an embedded system. Now, if we take a look at some of these examples here, we have the thermostat. Essentially, right, an embedded system is a system that has one or limited functions. Smart thermostat, heat your house. Sat-nav, guide your way whilst you're driving. Washing machine, wash clothes. As you can see from these, they have limited functions, okay? An embedded system is a system that has one or a limited number of tasks that it can perform. That's the definition of an embedded system, simple as that. They've got advantages over general purpose computer systems because their limited number of functions means that they're cheaper to design and build. For example, in a washing machine, you don't need the same kind of chip that's going to power a tablet. And they tend to require less power, Some devices even run from batteries as well, like the smart thermostat there, that can have batteries put inside it. And they don't need much processing power, so they can be built using cheaper processors. As I say, you don't need a super powerful processor for an embedded system because of the fact that it does one or limited number of jobs. So, my answer to this question would be something along the lines of, it has a specific purpose, okay? Its job is to follow the car in front of it and make sure it keeps the same distance without the driver getting involved. So it only performs one or limited tasks. It's built within a larger device. That's a key point of embedded systems. There's usually a larger device that it's built into. So for this one, it's a car. And it has a microprocessor, which is essentially a small processor. So that's question 3 about embedded systems. You need to know that they've got a specific purpose, limited tasks, built within a larger device, and they have a microprocessor. Question 4. A car comes with many embedded systems, for example, parking sensors. Identify one other embedded system that could be found in a car and explain why this is an embedded system. So you give an example, okay, like automatic lights, window wipers, sat-nav, GPS, climate control, radio entertainment, dashcam, and more. It's a similar question to the previous one. You're just saying, if you were to go for example, sat-nav or GPS, you would say it has a limited number of functions that it can carry out. Okay, so it's like explain why. So you've got to pick one of them and then explain why it's an embedded system. And because you know the characteristics of embedded systems, it should be pretty straightforward. Question number 5. Complete the table by writing the missing definition or name of each of the common CPU components and registers. So as I say, you need to know about the registers, right? So you may be presented with it like this. There are similar questions. It might say, describe 2 registers. You might have to read a description and identify the register. This one's just presented in a table. So it says, stores the address of the next instruction to be fetched from memory and increments during each fetch execute cycle. So this is counting the instructions that are happening during the cycle, hence why this would be the program counter. With this one here, it says you've got to define what the control unit is. So the control unit is the boss, all right? It sends signals to run or control the fetch, decode, execute cycle. Sends signals to coordinate, run, or control the FDE cycle. Now it says, stores the address of the data to be fetched from, or the address where the data is to be stored. Now, because of that key word, address, you should know that that's the memory address register, or the M.A.R. Easy one to remember. This one performs mathematical calculations and logical operations. So this one is going to be the arithmetic logic unit because it does arithmetic logic stuff. Quite simple. Again, just understanding what the registers are, what they do. The question is just presented in a different way, whereby instead of identifying 2 and explaining, you've got a table. 4 marks. Something different now. Question 6. A computer system has a 2.5 gigahertz processor and 5 gigabytes of RAM. Von Neumann architecture includes registers. Identify 2 registers used in the von Neumann architecture. Again, it's asking you about registers, right? As long as you know what they are, you can just identify them. It's just 2 marks. You've just got to say what they are. They're all here, look. PC, M.A.R, M.D.R, accumulator. Nice and simple. Question 7. State the purpose of the CPU. Well, the job of the CPU is to carry out the fetch, decode, and execute cycle. Again, it's as simple as that. That's what happens in the CPU. That's why all those registers work together. It's the part of the computer which is responsible for processing instructions, as you can see by the graphic here. So you can basically say it processes instructions, carries out the FDE cycle. Right? That's the best answer, the top one there. Question 8. Again, this is about registers, but this time it's a little bit more tricky because you've got 5 potential definitions, right? So you've got to draw one line from each part of the processor to match the correct definition. So you need to think about here, the control unit. I wonder what the control unit does. Now, what the control unit does is it sends signals to direct the operations. Because of the control part, it directs all the operations. Then you've got the cache. Okay, now the cache is that high-speed memory that's inside the CPU that stores recently used instructions for quicker access. Therefore, the line from cache needs to go to the bottom one. ALU, always remember, arithmetic, okay, maths. And for that reason, the ALU goes to the top one, performs mathematical operations. Register, okay, so we've got the register now. You've either got two options here. Keeps the clock in sync. Well, no, that's not what a register's for, so it must be the other one. A small piece of memory inside the processor that can hold one instruction or address. All right, nice and simple. That's what the registers do. That's how they all match up. So again, like I say, it's just having that knowledge of the registers, what they do. These are components of the CPU. They're not all registers, but it's just having that knowledge of what each of these things is for and being able to match it up to a description. Question 9 or 10, I'm not sure. It says, give 3 characteristics of a CPU that can affect its performance. Now, you've got to remember the 3 C's: clock speed, cache size, and cores, or number of cores, okay? So the clock speed, the cache size, and the number of cores. That's it, right? 3 characteristics of a CPU that it can affect its performance: clock speed, cache size, number of cores. Now, you're not required in this question to explain any of them. It's just 3 marks, 3 characteristics. They are the ones. Remember the 3 C's: clock speed, cache size, cores, okay? We'll go into a bit more detail soon about what each of them are. Question 11. Ivy's tablet computer has an operating system. Ivy thinks her tablet is an embedded system, and state whether Ivy is correct or incorrect, and you're justifying your choice. Okay, so the first part of that question is correct or incorrect. Let's have a little look at general purpose systems and what's included. We have desktops, we have tablets, we have laptops, and we have phones. These are general purpose because they carry out more than one task. So she's incorrect, okay? Her tablet is not an embedded system because remember as well, embedded systems have one or limited functions, whereas the tablet has multiple functions. You can see here that would be, incorrect would be the first mark, that would be 1 mark, and that would be the third, okay? Another example here, the tablet is general purpose, embedded system is single chip. Tablet has multiple chips combined because a tablet can have a dual core or a quad core processor, which means it has more cores. Embedded system is part of a larger system, whereas the tablet is a self-contained system and you can update the software on it. That means it's a general purpose system. Now, guess what? On question 12, I've got another question about registers. It's a table. Excuse me. You've got some descriptions and you've got to put a tick in the box to identify which component each statement describes. Now, it does say here, what you have to remember is that it says tick 1 or more boxes in each row. The or more is quite important because there might be more than one thing that it relates to, okay? It stores a single address. Hear the word address? Think memory address register. So that's got to be one of the ticks. The program counter also stores an address. It stores frequently used instructions. Frequently used instructions, in terms of this question, within the CPU, that's going to be cache. It is a register. Well, look at M.A.R. and M.D.R. The R stands for register, so that's a register, that's a register. And we also need to remember that the program counter is a register. So you've got 3 there. You get 1 mark per correct row. It stores all currently running data and instructions. That's the job of RAM, primary storage. Okay, so you can see there that there is 1 or more ticks in some of the rows. So even if you don't know all of them, if you at least put a tick in each row, then you may get a mark, because as you can see, the second and the fourth descriptions have 1 tick in the box. So you never know, you might get it right. See the two computer specs below. Computer 1 is likely to run faster. Identify one reason for this. Now, performance, running faster, that's all about CPU performance, right? Because here you can see clock speed, cache, and cores. Computer 1, let's look at the clock speed. 1 gigahertz. Computer 2, 1.4 gigahertz. Cache 2 megabytes for each, and cores 2 and cores 4. Now you may assume that computer 2 is going to be faster because if you look at it on a first glance, it says 1.4 gigahertz, which is faster, although there's an X there when it should be a Z, so apologies for that. But what makes it faster, why computer 2 will really run faster, is because it has more cores, okay? This has got 2 cores, computer 1, and computer 2 has got 4 cores. This one, again, is about the 3 Cs. It says why cache size can affect the CPU performance. So, cache memory is a small but extremely fast type of memory. It is closer to the CPU, right? So it can request data from the cache before the RAM, which makes it a little bit quicker because it saves fetching the instructions and data repeatedly from RAM, which is further away, and transfers take less time from the cache than they do from the RAM. So the answers to those ones are data is transferred faster, which makes the CPU more efficient. Where there's 2 marks, you've usually got to say 2 things, or try to do an and or a which or a because, okay? It is faster to transfer to and from cache, cool, than transferring to and from RAM. You're explaining things in 2 ways there. The question numbers are a little bit messed up here, rather, but question number 14 or 15 or whatever it is, explain one reason why cache size affects the CPU performance. It's the same question, same slide, just making sure that this is embedded in your brain. Okay, now question 15. Identify 2 events that take place during the fetch, decode, execute cycle. Okay, so we're saying 2 things that happen during the FDE cycle. If we go back to the first slide, there's a whole diagram there, if you rewind the video to the beginning, with all the things that happen at each stage of the fetch, decode, execute cycle, okay? And these are all the things that you can use or that happen. So we've got an instruction is fetched from memory. Yes, it is. That's the first thing that happens, remember. I always say that one because it's the first thing that happens. An instruction is fetched from memory, i.e. RAM. The instruction is then decoded. The decoded instruction is executed, so the CPU performs continuously. The process is repeated. The program counter is incremented. The instruction is transferred to the memory data register, and the address of the instruction to be fetched is placed in the memory address register. All right, and it happens again and again and again. Please just remember the things that take place during the fetch, decode, execute cycle. And no matter how these questions are presented to you, you should be able to answer them without a problem. So that was a quick rundown of some of the questions that you might face in terms of the systems architecture topic in GCSE computer science. If you want to see more videos like this, please like, please subscribe, and I will keep posting and you will smash your exams, okay? The slogan on my channel, by the way, is learn it, revise it, smash it. All right. Thank you very much.